Hello and welcome. This is Haroon Rasheed from Department of Electronics and Instrumentation Engineering from Vienna Vignan Jyoti Institute of Engineering and Technology. Today we will be discussing the topic process control instrumentation, introductory topic. So, process control instrumentation. From the name itself, we can understand that it's about the control system which is controlling a process. A process can be a simple process like controlling a room temperature, which our air condition does. Okay, it could be a control of a level of water in tank or some chemical in tank, or it could be a complex industrial process like manufacturing of cough syrup in the pharma industry, or it could be like control of turbine in power plant. It could be anything, a distillation column. It could be so, in this subject, we deal with the control system which is controlling the process. As part of introduction, first of all, we should understand what what is the building block of process control. Okay, we shall take a simple example. Process control also includes in our day-to-day life, like while we talk, while we walk, we are climbing stairs, so it includes the process control. And a simple activity of filling water bottle with water also includes a process control. Second, for example. So while filling the bottle, what we do, we grab bottle in our hand. Okay, we visualize, we understand that the bottle is empty. So we open the tap with our hand. As initially bottle is empty, we will be opening the tap fully. Consider the tap which gets open with multiple rotations. Okay, in that case, we open the tap fully so that we can make maximum inflow possible to fill the bottle as soon as possible. Initially, we have realized that the bottle is empty, so we want full inflow to happen. So, as soon as we open the tap, the water gushes inside the bottle as the level of water starts to rise. Okay, we also realize that the how fast the level of water is rising. Okay, our brain makes even that calculation, and as the level of water, if it is rising very fast, way before the bottle is getting full, we start to close the valve. Brain commands our hand to close the tap before, way before the water is reaching to the bottle neck. uh, Here we can understand few things. One is we are understanding the status of liquid in the bottle, water in the bottle. With our eyes, we are visualizing it. So eyes are acting as sensors. Okay, here our brain is acting as a controller, and our hand, by which we are opening and closing the tap, is acting as a actuator. Okay, so we have five sensory organs. So these five organs are sensors given by the nature. We are having brain as a controller, and we are performing day-to-day activity in a controlled way. So if I convert the same example with the level with an, in an industrial example, so I can consider a tank instead of bottle. Okay, I want to control level of water or some chemical X in the tank at a height, particular height h. Okay, so as we are using eyes as a sensors, here we need a sensor which could be a level transmitter or level sensor. Transmitter is nothing but a sensor with electronics which converts the sensed process variable and converts into the electrical signal so that the controller can understand in the industrial standard, which is like 4 to 20 milliamps or 1 to 5 volts. Okay, so now as this sensor gives the feedback or input to the controller the status of process variable. As in the case eyes, our eyes, if as a sensor, were giving a feedback to our brain what is the status of water in the bottle. Okay, now controller, based on the given set point, here in the case of bottle, the set point was the bottleneck. We want to fill the bottle up to the bottleneck. So this was my set point. Here the set point is the level at which I want to control the water or the chemical inside the tank. It could be somewhere like here. But I have to tell the controller that this is the set point, so that the controller can understand the difference between the real process variable and the set point, so that it can command the inflow. It can manipulate the inflow so that the height of the liquid gets controlled precisely at the set point. Okay, in this case also, our brain actually what it is doing, it's calculating the difference between the set point and the current status of the water in the bottle. When it is empty, so the difference is very high, so brain commanded our hand to open the valve or this tap fully. As the water level was rising up, the brain start to command to slowly reduce the inflow of the water in the bottle, and precisely we are able to control the water in the bottle precisely at the bottleneck without spilling it. We will be avoiding the spilling of the water from the bottle perfectly. So the same thing happens here. The controller compares the process variable, which is an electrical signal given by the level transmitter. It transmits the status of liquid in the tank to the controller, and controller compares the process variable, which is the level of the water or chemical, with the set point. So it generates a signal. We call it as an error signal. If we see how we draw in the form of block diagram, if this is the controller, okay, this is a process. Okay, so in our case the process is level process. We are controlling level of liquid in a tank. Okay, so now this level is sensed by level transmitter and given as a feedback, and here we will be giving like set point as an input. Okay, now the status of the level of the liquid in the tank is fed back, and it is one actually it's a part of a controller. This error calculation, what we are doing here, it does a calculation like E is equals to, we can write in this way, set point minus process variable. Okay, so a simple arithmetic operation is done for calculation to calculate the error. So this operation is done like for example, say if x is the level of the liquid in the hand, sorry, we are considering h as the level of the liquid in the tank, and it is compared with set point, which could be like y. So it could be y minus h. E is equal to y minus h in this case. So when there is an error, it means the process control is not at the process variable is not at the set point. So this error is communicated to the controller, and based on this error signal, the controller will manipulate the process variable. In this case, we are manipulating the inflow to control the height of the liquid in the tank. So when they in the case when set point is equal to process variable, then this error signal will be 0. In that case, no control action will be taken place. When there is a deviation from of process variable from the set point, in that case that this error signal is generated, and based on this error signal, based on the magnitude of this error signal, the controller performs the control action to the on the process variable, manipulated variable. So in simple words, what we are doing is we are controlling level of the liquid in the tank, okay, by controlling the inflow. For example, we can say Fin, okay. Now this Fin is manipulated by the controller, so it can be called as manipulated variable. The height of the liquid in the tank which we are controlling, it can be called as a controlled variable, or in a few textbooks it is also written as a process variable. Either CV we can write it as, or we can write it as a PV. Okay, so this is about a simple introduction how controller works in the real time uh, in the process control instrumentation. Thank you.